Dear students, in today's video, we are going to discuss electrostatic potential. The questions may appear in the exam that develop the concept of potential difference and electric potential. Potential difference and electric potential are two different terms. There is a slight difference between these two terms that we will study in this video, and state and define the SI units. To understand the concept of potential difference, we consider a source charge, that is plus Q. This source charge is placed at point O. We know that the electric field lines are directed outward from the source charge plus Q. So at this point, the electric field has this direction. Then we have a test charge which is placed at point A. We try to move the test charge plus Q0 towards the point B. As we know that the plus Q charge has its electric field around it, and you are bringing this plus Q0 test charge in the field of the source charge, due to which the repulsive electrostatic force will act on the charge plus Q0. So, some work has to be done to move the test charge from point A to point B. This work is WAB. That is the work done while moving the plus Q0 charge from point A to B. Then, potential difference V is given as VB. The potential at point B minus VA is equal to the amount of work done in moving the test charge from point A to B divided by the amount of the test charge. This is the expression for potential difference. You need to learn this expression, as many numerical are based on this expression. So if the potential difference is to be defined, the definition is potential difference between the 2 points in an electric field, that is, the electric field is generated by the source charge, may be defined as the amount of work done in moving the unit positive charge without accelerating from one point to the another point against the electrostatic force. Because both the charges are positive, the repulsive electrostatic force is present over there. Now, the unit positive charge, the word is used over here. What do you mean by unit positive charge? Unit positive charge is plus 1 coulomb charge. Unit means plus 1, right? So, the test charge is selected in such a manner that it is so small, it will not disturb the distribution of source charge. Secondly, the external force doesn't appear any kind of acceleration of the test charge. Next is the electric potential. Now we will clearly see that how this electric potential is different from the potential difference, right? So in this case, we have chosen the point A. The point A where your test charge is initially present. We have chosen the point A at infinity. Means your source charge is present here, while the test charge on which you want to experience the potential difference is at infinity. Means it is at a very large distance from the source charge. So VA will be equal to 0. Potential at point A is equal to 0. So electric potential at a point located far away from the source charge is taken as a 0. So VA is equal to 0. With VA is equal to 0, your equation will take this form, because initially you was having V is equal to VB minus VA equal to WAB by Q naught. Now WAB is just written as W, and this VA is substituted equal to 0, right? In this equation, the W is the amount of work done in moving the test charge from infinity to the point B, right? Means this point A now lies at infinity, and you are bringing test charge from infinity to point B, right? Where VB is the potential at point B. So the electric potential at a point in an electric field can be defined as amount of work done in moving a unit positive charge from infinity, not from a point A, we are writing from infinity to the point against the electrostatic force, right? So electric potential is the ratio of work done by the charge. Work done has SI units as joule. Charge has a units of coulomb. Units of electric potential is volt. It is represented by the symbol V. So if you write electric potential as 1 volt, then 1 volt will be ratio of joule to coulomb, and it is joule coulomb inverse or coulomb raised to power minus 1. Joule are the units of work, and work is given as dot product of F vector and ds vector. So force into displacement. Force has SI units of Newton and distance is measured in meter. So Newton meter can replace your J and C inverse, right? So 1 volt can be also written equal to Newton meter per coulomb. We can say the electric potential at a point to be 1 volt if 1 joule work has been done in moving the unit positive charge of 1 coulomb from infinity to that point against the electrostatic force. So 1 volt is the ratio of the amount of work, that is 1 joule, which is done for moving the unit positive charge of 1 coulomb from infinity to a certain point against the electrostatic force. Let us calculate the dimensional formula for electrostatic potential or electric potential. The electrostatic potential is the ratio of work upon charge. Work can be written as force into displacement. First of all, let us calculate the dimensions of charge. The charge upon time gives us current, and we know that the charge is the product of current into time, and dimensions for current are written as A, ampere, and time is T. So you can replace your charge with A and T. Then the force is mass into acceleration, so it is mLT minus 2 mass m. LT minus 2 is for the acceleration multiplied with the distance, that is again L, so one more square will be here, so it is mL square T minus 2. On simplification, we get these are the dimensions for electrostatic potential. This is all about today's video. Thank you.